Imagine drifting through the darkness of space and seeing something that should not exist. At first, it looks almost completely black, like an empty hole punched through the universe. But as you get closer, the stars around it begin to twist. Their positions seem wrong. Light bends around an invisible center, creating strange arcs and glowing patterns across the darkness. And then surrounding the blackness, you begin to see an enormous ring of light moving at unimaginable speeds. You are approaching a black hole. But what would you actually see before you fall beyond the point of no return? Would everything suddenly become dark? Would you see the future of the universe? Or would the last thing you see be something far stranger than you ever imagined? Before we get anywhere near the black hole, there is something important to understand. A black hole does not usually appear as a giant black sphere floating in space. The black hole itself does not shine because light cannot escape from within its event horizon. What you can see is the effect it has on everything around it. If there is gas, dust, or other matter falling toward the black hole, that material can form a gigantic rotating disk. As gravity accelerates this material to incredible speeds, friction and compression can heat it to millions of degrees, causing it to release enormous amounts of radiation. From a distance, you could see an intensely bright structure surrounding an almost perfectly dark center. The brighter the material around it becomes, the more dramatic the darkness at the center appears. As you move closer, something even stranger begins to happen to the stars behind the black hole. Normally, light travels through space in nearly straight lines. But according to Einstein's theory of general relativity, gravity is not simply a force pulling objects through space. Massive objects curve space-time itself, and light follows those curves. A black hole creates an extreme distortion. Light from stars that should be hidden behind it can bend around the black hole and reach your eyes. As a result, the sky would begin to look distorted. Stars could appear stretched into arcs, duplicated, magnified, or shifted into unexpected positions. The universe around you would start looking as if someone had taken the night sky and twisted it around an invisible point. Then you would notice something even more remarkable. The black hole could appear to have a glowing ring around its shadow. This is related to gravitational lensing and the behavior of light extremely close to the black hole. Some light can orbit the black hole along unstable paths before escaping. From the right position, this can produce a thin, brilliant structure surrounding the dark region. The image would be unlike an ordinary object in space. You would not simply be looking at a black circle. You would be looking at a region where space and light have been distorted so severely that the background universe is being wrapped around it. But the closer you get, the more extreme the distortion becomes. Light coming from distant objects can become increasingly shifted and distorted. The direction from which you see the outside universe no longer corresponds to the direction you would expect from ordinary geometry. The black hole would effectively change your view of the cosmos. In some directions, you could see light that had traveled around the black hole before reaching you. In others, the black region would dominate your field of view. You would be surrounded by a strange mixture of darkness, distorted stars, and, if matter were present, an incredibly bright disk of superheated material. And then there is time. As you fall toward the black hole, your experience and the experience of a distant observer begin to diverge. From your own perspective, your clock continues to tick normally. You do not feel your personal time suddenly stop simply because you're approaching the event horizon. But an observer watching you from far away would see your signals become increasingly delayed and shifted toward longer wavelengths. The light carrying information about you would become weaker and more difficult to detect. From their perspective, you would appear to approach the event horizon more and more slowly, while your image becomes increasingly faint. This creates one of the strangest illusions in the universe. Imagine someone watching from an enormous distance while you fall toward the black hole. They would never receive a normal visual signal showing you casually crossing the event horizon. Instead, the light coming from you would become increasingly delayed and redshifted. Eventually, you would fade from their view. But this does not mean that from your own perspective you have stopped moving. you continue falling. The difference comes from the way gravity affects the passage of time and the paths followed by light. Now imagine that the black hole is supermassive, perhaps millions or billions of times more massive than the Sun. Surprisingly, this could make the journey across the event horizon less immediately violent than you might expect. The event horizon of a supermassive black hole can be enormous, and the change in gravitational strength across a human-sized distance near the horizon can be relatively small compared with that of a much smaller black hole. You would not necessarily encounter a physical wall. There would be no surface to crash into. No cosmic barrier would suddenly appear in front of you. The event horizon is a boundary in space-time, not a solid object. But what would you see when the outside universe is behind you and the black hole is surrounding you? The answer becomes difficult because our everyday understanding of direction and distance starts to break down. Light from the outside universe can still enter the region you are falling through, meaning the sky would not simply disappear the instant you cross the event horizon. Instead, the outside universe would appear increasingly distorted into a smaller region of your sky as your possible future paths become constrained toward the black hole's interior. And this leads to one of the most famous misconceptions about black holes. You would not necessarily see the entire future history of the universe play out in front of you as you fall through the event horizon. The idea that you could watch billions of years of cosmic history accelerate before your eyes is a popular interpretation, but it is not what a falling observer simply experiences. Your own proper time remains finite. The physics of what you see depends on the black hole's geometry, your trajectory, and the light that can actually reach you. The universe does not turn into a giant fast-forward movie. If the black hole has a powerful accretion disk, however, the visual experience could become extraordinary. The disk might appear warped above and below the black hole because light from its far side can bend around the black hole and reach you. You could potentially see portions of the disk that would normally be hidden from a straightforward view. Instead of looking like a simple flat ring, the disk could appear to wrap around the black hole, creating a complex structure of glowing arcs and loops. What you are seeing is not the black hole itself shining. You are seeing light being forced to travel through severely curved space-time. As you continue falling, the outside universe becomes less and less accessible. The event horizon is now behind you, and there is no path back to the outside. This is the defining feature of a black hole. It is not simply that escaping would require an enormous amount of energy. Inside the event horizon, the geometry of space-time is such that moving toward the center becomes unavoidable for anything following a future-directed path. The black hole is no longer something you are merely approaching. You are now inside it. And then comes the final mystery. Deep inside the black hole, according to classical general relativity, you would eventually approach the region known as the singularity. But this is where our current theories stop giving us a complete picture. General relativity predicts conditions of extreme space-time curvature, while quantum physics should also become important. We do not yet possess a complete theory of quantum gravity capable of describing exactly what happens under these conditions. So anyone claiming to know exactly what you would see at the very end is going beyond what current science can confidently establish. Perhaps the most astonishing part of this journey is that the black hole itself would not need to look dramatic from a distance. It could appear as a dark region against the stars. But as you approached, gravity would transform the entire appearance of the universe. Stars would bend into arcs. Light would follow paths that seem impossible. Matter around the black hole could shine brighter than entire collections of stars. Time would behave differently for different observers. And eventually, a boundary would separate you from the rest of the universe forever. So what would you actually see before falling into a black hole? You would not simply see darkness. You would see the universe itself distorted by gravity. You could see stars appearing in places where they should not be. You could see light bending around an invisible center. You could see a brilliant disk of superheated matter surrounding an enormous shadow. And as you approach the event horizon, the familiar geometry of the universe would gradually give way to something that our human intuition was never designed to understand. A black hole is therefore more than a mysterious dark object in space. It is a demonstration of how far the laws of physics can push reality. It shows us that space can curve, time can pass differently for different observers, and light itself can be forced to follow paths that would seem impossible in ordinary life. And perhaps the strangest thing of all is that when you look into the darkness of a black hole, you are not simply looking at an absence of light. You are looking at one of the places where our understanding of the universe reaches its deepest limits. The next time you look at the stars, remember this. Somewhere in the universe, there may be a black hole surrounded by a glowing disk, bending the light of distant galaxies around it. And if you could approach it safely enough to observe the view, the universe would not look like the one you know. It would look as though reality itself had been stretched, twisted, and wrapped around a point of no return.